With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, the question is a heat engine carries 1 mole of an ideal monoatomic gas around the cycle as shown in the figure. The amount of heat added in the process AB and the heat removed in the process CA are. So in this question we are given that a heat engine that carries 1 mole of an ideal monoatomic gas around this cycle, the amount of heat added in the process AB and amount of heat removed in the process CA we have to calculate. So first of all, the amount of heat that would be added in the process AB. So process AB is at constant volume because at this the volume is constant from A to B. So we can write the process AB A to B, this is isochoric as it is at constant volume. And the process, that is the heat removed in the process AC, so that is at constant pressure, so it is isobaric. So process C to A, this is isobaric as the pressure is constant in this. Now according to first law of thermodynamics, the change in internal energy, that is equal to the heat involved, delta U is equals to Q plus delta W. Now if the work is done at constant volume, as work is minus P dV, if volume is constant, it means dV or delta V will be 0. So if delta V is 0 or dV is 0, so work done will be 0. It means in this case, if delta W is 0, so delta U will be equals to delta Q or Q. That is the change in internal energy is equals to the amount of heat. Now we are given a monoatomic gas. So for monoatomic gas, CV is equals to 3 by 2R and Cp minus Cv is equals to R. That is, Cp is the specific heat capacity at constant pressure and Cv is the specific heat capacity at constant volume. So if we know Cv, that is it is 3 by 2R, so Cp will be R plus 3 by 2R, that is 5 by 2R. Now if we have to first find out the heat that is absorbed or added in the process AB, so we will write QAB, so that will be equals to NCV dt, because this is the process at constant volume. So we will use QAB, that is equals to change in internal energy, and it will be involved as NCV delta T. So N we are given is 1 mole, CV for monoatomic ideal gas is 3 by 2R, and delta T, change in temperature, we will see from the graph, that is the initial temperature is 300, this temperature, and final temperature is 600 Kelvin. So T2 minus T1 will be 600 into 600 minus 300, that is T2 minus T1. So this will give us 3 by 2R into 300. So this will be 450R, and this is in positive. It means this is the heat added or absorbed in AB process, that is plus 450R. Now the heat that is involved in CA process, which is at constant pressure, So at constant pressure it will be NCP delta T, and N is given to us, that is 1 mole of monoatomic ideal gas, and Cp for monoatomic ideal gas is 5/2R, and delta T is the final temperature minus initial temperature. So final temperature is 450 Kelvin, T3 minus T1, and T1 is 300, so it will be 450 minus, sorry, it is 300 minus 450, because the process is from C to A. So for CA process we have to find out the amount of heat that is released. So that would be, the initial temperature is 450 and final is 300, so it will be 5/2R into minus 150. So this gives us as minus 375R. Now the minus sign, this indicates that the heat is released or removed from the system. Heat is removed or released. So heat which is added in the process AB is plus 450R, and heat which is removed from the CA process is minus 375R. So correct option will be QAB is 450R and QCA is minus 375R. So C option is the correct option to this question. I hope you understood the solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.